Have you ever stood by the sea on a misty day and wondered what lies beyond the horizon? It is a question that stirs something deep within us. A similar, grander question has been asked by thinkers for centuries. It is a question that touches the very limits of our imagination and our knowledge. What lies beyond the edge of the universe? This query sounds as if it belongs in ancient myths or quiet fireside stories. Yet, it is also one of the most profound and active questions in modern science. We can approach it not with fear, but with a gentle and warm curiosity. This is not a question with a simple answer waiting to be found in a textbook. It is an exploration. It invites us to think about the nature of space, time, and our own place within this vast cosmos. To ask what is beyond is to acknowledge the boundaries of our own perception. It is to be humble in the face of immensity. The journey to understand this concept is as important as any final answer we might discover. It is a quiet, persistent whisper in the soul of science, asking, is this all there is, or is there more? Before we can ponder what lies beyond, we must first understand the boundary itself. We must speak of what scientists call the observable universe. This term does not describe the entire universe in its totality. Instead, it describes only the portion of the cosmos from which light has had time to reach us here on Earth. Imagine it as our personal cosmic window. We can only see the things whose light has completed the long journey to our eyes, to our telescopes. It is a simple concept, yet it holds a profound truth about our perspective. The universe, as we best understand it, began approximately 13.8 billion years ago. Since that moment, light has been traveling outwards from every point, spreading through the fabric of space. The light from the most distant galaxies we can see today began its journey very close to that beginning. It has traveled for nearly the entire age of the cosmos to finally arrive here. Anything that is farther away than that has sent out light that simply has not reached us yet. This creates a sort of sphere of vision with Earth at its very center. This sphere is the observable universe. The distance to its edge, or its cosmic horizon, is about 46.5 billion light-years in every direction. You may wonder why that number is so much larger than the universe's age of 13.8 billion years. This is because space itself has been expanding the entire time that light has been traveling, stretching the journey out over an even greater distance. It is crucial to remember this one point. The edge of the observable universe is not a physical wall. It is not a cliff at the end of space. It is a horizon of information, a limit to our current vision imposed by the finite speed of light and the age of the cosmos. Just as a ship sailing away from you eventually disappears over the horizon of the sea, distant galaxies disappear over our cosmic horizon. This does not mean they are gone. It only means they are, for now, beyond our sight. That is the idea. The question of what lies beyond our sight has always driven humanity forward. Ancient mariners sailed into unknown waters, guided by stars and guided by courage. Astronomers built larger telescopes to peer deeper into the night sky, revealing galaxies where once there was only darkness. To better grasp this idea, let us use a simple and clear analogy. Picture yourself standing on a sandy shore, looking out over a vast and endless ocean. Waves crashing near your feet, boats sailing in the nearby harbour. Your vision extends for many miles across the water, to a point where the sky seems to meet the sea. This point is your horizon. Everything within this horizon is your observable sea. It is all that you can see from your specific vantage point on the shore. You know, with perfect certainty, that the ocean does not simply stop at your horizon. Beyond that line of sight, the water continues. There are likely more boats, more waves, perhaps distant islands you cannot perceive. Another person on a different shore, miles away. They would have their own horizon and their own observable sea. Their view would overlap with yours. but they would see parts of the ocean hidden from you. This is very similar to how the observable universe works. Our planet is like that single spot on the shore. The light reaching us is like the view across the water. The edge of the observable universe is our horizon. It is a boundary of perception, not of reality. There is no logical reason to assume the universe itself ends where our vision currently fails. It is far more likely that the cosmos continues on, stretching far beyond what our telescopes can presently detect. Here is another picture that may help. This one helps us understand the role of expansion. Imagine you have a balloon that is not yet inflated. Take a pen and cover the surface of the balloon with many small, evenly spaced dots. Each one of these dots represents a galaxy. Now begin to slowly inflate the balloon. As the rubber stretches, you will notice that all the dots are moving away from each other. The space between them is growing. Now imagine you are a tiny observer standing on one of these dots. As the balloon inflates, you look around. The dots nearest to you seem to be moving away slowly. But the dots on the far side of the balloon are moving away from you very, very quickly. In fact, if the balloon were expanding fast enough, some of the most distant dots would be receding from you faster than light could travel across the balloon's surface. Their light would never be able to reach your dot. The portion of the balloon's surface that you can see, where light has had time to reach you, is your observable universe. It is just a patch on the much larger surface of the balloon. There is no true center on the surface of the balloon, just as we believe there is no true center to our universe. This analogy beautifully illustrates two key ideas. Section 5. Possibility 1. An infinite expanse. So, what might we find if we could somehow peek beyond that cosmic horizon? The first and perhaps simplest possibility is also one of the most staggering. It is the idea that the universe just continues. It goes on and on, perhaps forever. Beyond our observable bubble of space, there is simply more space, more galaxies, more stars, more planets. It would be a cosmos that looks, on the grandest of scales, very much like the one we already know. This is known as the infinite universe model. This idea fits well with our current observations. When we look at the universe on a very large scale, it appears to be remarkably uniform. The distribution of galaxies looks roughly the same in every direction we look. This is called the cosmological principle. If the universe looks the same everywhere we can see, the simplest assumption is that this pattern continues everywhere we cannot see. The physical laws that govern gravity, light, and matter would be the same in those distant, unseen regions as they are here. If the universe is indeed infinite, then some mind-bending consequences follow. With an infinite number of galaxies, there would be an infinite number of stars and an infinite number of planets. In such a limitless expanse, the laws of probability suggest that somewhere, far beyond our horizon, there could be another planet just like Earth. In fact, in a truly infinite universe, there would be infinite copies of Earth and infinite copies of you, living out lives that are nearly identical or, wildly different. Let us now consider a second, more exotic possibility. What if the universe beyond our view is not just more of the same? What if far beyond our cosmic horizon, the fundamental rules of reality itself are different? Imagine our observable universe as a calm, temperate region on a vast continent. But beyond the mountains that form our horizon, there could be strange deserts, frozen landscapes where the very laws of nature operate differently. This is the idea of a non-uniform universe. The constants of nature we hold dear might not be constant at all. For example, the strength of gravity might be slightly stronger or slightly weaker in another domain. The charge of an electron could be different. If these values changed, even tiny amounts, that region's universe would be unrecognizable. A slight change in the strong nuclear force could make atomic nuclei unable to hold together. Stars, as we know them, could not form. Such a region might be a dark, empty void, or it could be a chaotic maelstrom of energies and particles. The laws of physics we've uncovered would be merely local bylaws, applicable only to our particular neighborhood of space-time. Our science would be the science of our patch, not the science of the whole. This idea is humbling and a little unsettling. While speculative, it's not without scientific basis. Some cosmological models that try to unify forces suggest physical constants could have settled differently in different regions of space during the earliest moments after the Big Bang. The third idea is perhaps the most famous and the most mind-bending of all. It is the concept of the multiverse. Our entire universe, even the infinite parts we cannot see, is just one bubble in a frothing sea of other universes. Each bubble could have burst into existence from its own Big Bang. Each could be expanding and evolving on its own, completely separate from ours. Beyond the edge of our universe is not more of our universe, but an endless expanse of parallel universes. This idea comes from a theory called eternal inflation. Inflation was a period of hyperfast expansion in the first fraction of a second. Eternal inflation says that while expansion stopped here, it may continue elsewhere forever. Like bubbles in boiling water, new universes form all the time, each inflating into its own vast space. Each bubble universe could be wildly different. Some might have different fundamental laws of physics. One could have 10 dimensions of space, another only 2. In one, gravity might be repulsive. In another, the speed of light could be much slower. Among infinite bubbles, some would by chance have laws like ours. Some might even be near identical copies. It's a breathtaking idea. The answer to what is beyond the universe could be more universes. We live in one chapter of a book with infinite pages, each page a different cosmic story. With such grand and varied ideas, one might ask how scientists can ever hope to find an answer. It is true that we cannot simply build a telescope powerful enough to see beyond the observable universe. The speed of light itself forbids it. We cannot send a probe to visit another bubble universe. Does this mean the question is forever beyond the reach of science, doomed to remain in the realm of pure philosophy? Perhaps not entirely. The search for answers is a quiet and patient one, relying on cleverness and indirect clues. Scientists are masters of looking for echoes and shadows. One of their most powerful tools is the cosmic microwave background, or the CMB. This is the faint leftover heat from the Big Bang that fills all of space. It is a baby picture of our universe, taken when it was only about 380,000 years old. By studying the tiny temperature variations, the subtle ripples in this ancient light, cosmologists can test their theories about the universe's very first moments, including the period of inflation. If our universe is just one part of a larger, non-uniform structure, or if it once collided with another bubble universe, it might have left a subtle, large-scale pattern in the CMB. We have travelled far on our journey of the mind, from the shore of our observable world to the theoretical realms of infinite copies and bubbling universes. We must now return to our starting point, with the honest admission that the true answer to our question remains unknown. We do not know what lies past the edge of the observable universe. We have elegant ideas, mathematical possibilities, tantalizing hints, but we do not have a definitive answer. And perhaps that is the most beautiful part of it all. This great unanswered question is not a failure of science. It is an invitation. It invites us to remain curious. It encourages us to keep building better tools, to keep thinking of new ideas, and to keep looking up at the sky with a sense of humility and awe. The mystery itself is a powerful engine for discovery. It reminds us that no matter how much we learn, there will always be new horizons, both literal and metaphorical, waiting to be explored. I would like to leave you with a final, gentle image.